Good morning, grade 10s. Good afternoon. Yeah, today is an amazing day. It's the day that the Lord has made. And let's see what we're going to be learning today. All right, so we're going to be dealing with inequalities today. All right, so inequalities. Okay, so I don't want you to be scared of this big name. All right, so basically all that inequalities are are basically just equations. Okay, but instead of using an equal sign, we're going to be using a greater than, a less than, a greater than, or equal to, or less than, or equal to sign. Okay, so this just means greater than, less than. Okay, it depends on where the x is. Okay, really. And then I just want to focus on this one over here. Okay, this just means that it's greater than or smaller than, depending where the x is. Okay, or equal to. Okay, so it's two things. So it's either equal to or greater than. Okay, so I just wanted to focus on that a little bit. Okay, but we're going to deal more with it later on in the video. Okay, so let's dive right into it. So if I look at this over here, okay, this is the graph of 2x plus 4. Okay, y is equal to 2x plus 4. I'm assume you guys remember what linear graphs look like from grade 9. Okay, so this should be somewhat familiar to you. Right? So if you look at this, and I'll ask you these questions, I say, after which x value is the graph above the x-axis? Okay, so if I look at this, okay, my x-axis is where? Is it the horizontal line or the vertical line? Okay, it's the horizontal line. That's my x-axis. Here's my y-axis. Okay, so if I'm looking for, okay, the x value, okay, where the graph is above the x-axis. Okay, so if I look at this, maybe I should color this in. Okay, make it look a little bit cooler for you. All right, so if I look at above the x-axis, okay, what am I talking about? Am I talking about this green area, or am I talking about this red area here at the bottom? Above the x-axis. Okay, so I locate where my x-axis is, which is over here. Okay, and my y-axis. Okay, so above my x-axis, if this is my line, above would be on top. Okay, so it's this whole green area over here. Okay, can you see that there's a point over here where my graph cuts my x-axis? Okay, and then it splits this line into two parts. Okay, it splits it into the green part. Okay, and then it splits this into the red part over here. Okay, can you guys all see that? Okay, so this graph, all right, we've got this green part over here. Okay, this green part. Okay, and then we've got this red part here at the bottom. Okay, so if you look at that and I say, for what x value, okay, from which x value, okay, up until where is my graph in the green area over here? Okay, so we already know that at this point, okay, what is this point called? What x value is this? -2. All right, can you guys all see that? That's -2. All right, so if I go to -1, all right, and I follow up and I go find where my graph is, there's my graph. Is my graph above or below the x-axis? It's above. Okay, and if I look over here, let's go to 1 for my x value. If my x value is 1, is my graph above or below the x-axis? It's above. It's in the green place over here. All right, so can you see that for all the values greater than -2 on my x-axis, okay, my graph is always going to be above. It's going to be in the green area over here. Okay, so just to answer this question over here, for which value of x, so after which x value is the graph above the x-axis? Okay, it's after -2. All right, so if x is greater than -2, all right, so if it's -1, it's above, it's above, it's above. All right, so every x value that is greater than -2 forever and ever, because remember this graph is going to carry on forever, it never stops. Okay, it goes on, it's always going to be above. All right, so now if I look at the second question, okay, it says which value of x, or which values of x, okay, is my graph going to be below? Okay, so where's my graph below? It's over here, the red one. All right, so am I going in a positive direction for my x values? No, I'm going this way. Okay, so that's where my graph is going to be underneath my x-axis. If I go more this way on my x-axis, so if I go to -3, and I follow down, I go find my graph. Is it above or below? It's below the x-axis. So for all these values to the left-hand side, okay, all these x values to the left, okay, my graph is always going to be below the x-axis. Okay, so I can say for all the x values smaller than -2, my graph is going to be below the x-axis. Okay, I'm hoping that's making sense. Okay, it's just a visual representation of what we're going to be doing with inequalities. Okay, so you don't really need to be using this right now in grade 10, but it will become handy if you can understand what I'm telling you a little bit more. It's going to come handy in grade 11 and grade 12 when you're going to be dealing with a whole bunch of other graphs and equations and stuff like that. Okay, so having some questions here. Okay, so solving for x. All right, so if I'm solving for x, that means I need to isolate something here. All right, but this is a funky looking thing. It's something new. Okay, I don't know what to do with that. So I'm going to treat it as if it is an equal sign. Okay, it's not an equal sign. Okay, it's not an equal sign. So don't change it to an equal sign because it's not. All right, but I'm going to treat it as if it is one. Okay, so when I'm dealing with an equation, a normal equation, so if I had something like this, equals 3, how did I isolate the x? I took all my numbers that way, and I kept my x's this side. Okay, so instead of now an equal sign, we just have this over here, a greater than sign. Okay, so I'm going to keep my 2x on the side. I'm going to take my number across. Okay, greater than sign. Okay, it's going to be 3, and if I take the 1 across, okay, it's going to be -1. Alright, let's simplify this side. Okay, so 2x is greater than 2. Right, and then how do I get x by itself? Yeah, okay, I'm just going to divide by 2 on both sides. Okay, same thing. Okay, and now the 2's cancel. Those 2's cancel. I'm left with 1 on this side and x on this side. Okay, so now this means basically, what am I telling you here? Alright, so I'm telling you that x is greater than 1, the value of 1. Okay, so now whenever you're doing an inequality, okay, you always want to represent the inequality on a number line. Okay, so what do I mean by number line? Okay, so if I look here, okay, I want to get a line here. Right, let's get a number line going. Alright, so if I look here, right, there's my number line. Alright, and what do they say that what do they say? What's the value that x is greater than? 1. Okay, so I'm going to mark just 1. I'm going to mark 1. Okay, anyway, I usually just use the middle of the number line. Okay, and then if you really need to, you don't really have to do this. You can put other values. You can say 0, you can say -1, and you can go a little bit up here. You can say that's 2, okay, that's 3, and so on and so forth if you really want to. Don't have to. Okay, so at the value of 1, okay, we know that x is strictly greater than 1. So does that include 1? If I say that x is greater than 1, okay, does that mean that x can ever be 1? No, because x is anything greater than 1. Not 1, but greater than 1. Okay, so that means we're going to use something, a symbol that looks like this. Okay, it's just an open circle. Okay, open circle, because it's not including 1. Okay, we're not including 1 in this. Okay, so we're starting at 1. Okay, and they say that all the x values are greater than 1. Okay, so all my values, all the values that are greater than 1, is it to the right of my number line or to the left of my number line? If I'm looking for all the values greater than 1, it's to the right. So I'm going to draw a nice little line here to the right and with an arrow. Okay, and there's my number line. Okay, so all this means, okay, is that for all the values of x, okay, so all these values to the right, okay, all these values here can be the value of x, okay, but not including 1 over here. Okay, so it could be 2, it could be 3, it could be 4, 5, 6, 7, and up until infinity. Okay, x can be any of those values except for 1. All right, I'm hoping that's making sense. All right, so moving on to the next example here. All right, so now I look at this and I see I've got something a little bit different. Something's a little bit funky here. Firstly, the sign is the other way around. Okay, it's the other way around, and also there's a little line underneath here. All right, what does that mean? Okay, that means smaller than or equal to. okay, smaller than or equal to, right? That just means that it can be all the values smaller than a specific value and also equal to that value, right? So we're gonna dive into this and we're gonna see what this means, okay? So again, I'm gonna treat it as if it's an equation, okay? I'm gonna take all my numbers this way, okay? Keep that the same way, all right? Take the 8 across, okay? And we've got 3 minus 8, right? We've got 5x smaller than or equal to negative 5. I just want x because I'm solving for x. Alright, so I'm going to divide by 5 on both sides. Alright, and then I'm going to have x on this side smaller than or equal to negative 1. Alright, so now whenever I've solved my x, okay, I've solved it, okay, whenever I'm dealing with an inequality, what do I want to do? I want to represent it on a number line. Okay, so let's get a number line going here. Alright, draw a nice number line there for you. Alright, and what do they say x is smaller than or equal to? Negative 1. So I'm going to label negative 1, okay, on my number line. Okay, now the sign is a little bit different. Okay, firstly, they're saying that all the x values are smaller than negative 1 and also equal to negative 1. So does that include negative 1? So if I say all the x values are smaller than or equal to negative 1, does that include negative 1? Yes, of course it does, okay, because it says there it's equal to as well. Alright, so that means it's also x could also be negative 1. In the previous example, x couldn't be equal to 1 because it says all the values greater than 1. Okay, not including it. Okay, and over here now it's all the values smaller than or equal to negative 1. Okay, so it's also equal to. Now we're going to use a different symbol. Okay, so we're going to draw a circle. Okay, but now we're going to include the negative 1. So we're going to color that circle in. Right, because now we're including it. Okay, and then they also said that all the x values are smaller than or equal to negative 1. So we've got the equal to. We included it. Okay, now what are all the values smaller than negative 1? To the left or to the right? All the values to the left of negative 1. Okay, so if you want me to, I can put some more values in here. There, negative 2, that's negative 3, negative 4. Can you see that all these values over here to the left are all smaller than negative 1? So all these values up until negative infinity are all smaller than negative 1. If I go this way, okay, so that's a 0, right, then it's 1, 2. Okay, all these values to the right are greater than negative 1, but that's not what they're looking for. They're looking for smaller than or equal to, color that dot in, negative 1. All right, happy with that? Okay, hoping this is getting a little bit easier. All right, so we're going to start moving a little bit quicker now. Okay, I hope you guys are ready. Let's get it. All right, let's move on. All right, so we're looking at this now. All right, so with this, there's something trickier. Not too much trickier, but there's something a little bit different here that I want to teach you guys. Okay, so let's just work up until this step. Okay, so what we're going to do is we're going to take all the numbers across. Okay, we know how to do that. Okay, smaller than or equal to 12 minus 6. So I'm going to have negative 3x. All right, smaller than or equal to 12 minus 6, which is just 6. Okay, now over here, I'm going to stop here. Okay, and I'm going to pause. And I'm going to go over here to the top. Okay, so usually what happens, okay, when I've got an equal sign, okay, so if I've got negative 3x equals 6, what do we usually do? We say we're going to divide by negative 3 on both sides, all right, and we're going to get negative 2, and this is going to be x over here. All right, so now let's apply this logic over here. Now I want to show you guys something, okay. What I'm going to do here, okay, firstly, I want you guys to know it's going to be wrong, okay, but I'm going to show you why, okay. So there's two ways you can do this, okay. So the first way is you can divide by negative 3, but there's something you need to do first. Okay, so let's just divide by negative 3 usually. Okay, so I'm going to divide by negative 3 on both sides. Fantastic, negative 3. And I want you to take note of where my inequality sign is pointing to. Okay, can you see that this point of this inequality sign is pointing to the x over here? All right, and I want you to keep notice of that. Okay, and in the open part of the inequality sign, is pointing to the number over here. Okay, I want you to keep note of that. All right. So here I'm going to have x. I'm going to keep that the same way. All right, and this is going to be -2. All right, so now I'm going to stop there. All right, and I'm going to come back to the top here. Okay, so I'm going to copy this back down. All right. Okay, that's this step over here before I divide it by 3. All right, so what I'm going to do instead of dividing by 3 is I'm going to take this -3x. I'm going to take it across this way because I want to make it positive. Okay, so let's do that. Okay, so if I take the -3x across, it's going to become positive 3x. All right. If I take my numbers to the other side, all right, I'm going to get, if this is positive 6 on this side, if I take it across, it becomes -6. Okay, can you see I just switched those around? Okay, so I took them across to the other sides, and then their signs changed. Okay, now what can I do to find x? Okay, I want you to divide by 3 on both sides. Awesome, awesome. All right, and now let's look at this. Okay, so this is going to be with x, all right, and this is going to be -2. Okay, but these two answers are different. Okay, why are they different? Okay, I want you to specifically look at the inequality sign here. Okay, can you see that this inequality sign, think of it as an arrow. Okay, the arrow is pointing towards the x. All right, cool. Now in this one, the arrow is pointing towards the -2. Okay, but now this is a bit different now. All right, so this is the thing. Okay, I'm going to tell you this is the right one. Okay, this is the right one. So whenever you are dividing by a negative number in front of x, whenever you're dealing with an inequality, there's something that you need to do. What is an easy thing that I can do to change the position of this inequality sign? Because at the moment it's pointing at the wrong thing. Okay, this arrow is pointing at an x, this arrow is pointing at a -2, and the open side is to the x, but this open side is to the -2. So what can I do to this inequality, okay, to make it point at the right things? Okay, I'm just going to flip it around. All right, so I'm just going to flip it around. Okay, so instead of it being like that, okay, simple things, I'm just going to flip it around. All right, I'm going to flip it to the other direction. All right, now can you see that the open side is to the x? The open side is to the x. Okay, the arrow is pointing to the -2, and the arrow is pointing to the -2. All right, easy. Okay, so this side is a little bit longer. It's fine if you solve your inequalities this way, perfectly fine. All right, but this is the quickest and easiest way. But there's something we must always remember when we divide by a negative, and only when we divide by a negative. Okay, what do we do when we divide by a negative and we're dealing with inequalities? We switch. We just flip the inequality, right? Because then it will be correct. All right, so knowing this, let's see if we can do the next example. Okay, so if there's anything about this that you didn't understand, okay, please rewatch the video. Okay, it's very important that you guys understand this part, right? Because I'm going to always be dividing by negatives when I'm dealing with inequality. Okay, now before we finish, okay, there's something I must always do when I'm done with an inequality. We always need to draw a number line, represent it on a number line. Right, so what did they say that x is greater than or equal to? -2. Okay, so I'm going to put that on my number line, put -2 there. Are they including -2? Yes, they're including it. Okay, so I'm going to draw a dot there, colored in dot. Okay, and they say that x is greater than or equal to -2. So all the values greater than -2, is it to the left or to the right? To the right. Okay, greater than -2. Alrighty. Okay, moving on to the next one. Alright, let's see if we can do this. Alright, boom, boom, boom. Ooh, I see fractions. I see fractions. Ding, ding, ding. What do I think immediately? Ooh, LCD. Okay, let's go do that. Okay, so we're going to get our LCD here. Alright, what I do on one side, I do on both sides. Alright, we know how to do this already. Okay, what I do to 2 to get to 2? Nothing. Okay, so that stays the same. 6 is over 1. 12 is over 1. What I do to 1 to get to 2? Times by 2. That becomes 12 now. Okay, what I do to 1 to get to 2 times by 2, and that 12 becomes 24. Alright, I don't like LCDs. I don't like LCDs. What must I do? Both sides. What must I do? Multiply by 2. Multiply by 2. Ooh, nice and happy. Okay, cancel, cancel, cancel. Here becomes negative 3x plus 12 smaller than or equal to 24. Right, get all my x's on one side, all my numbers on the other side. Okay, so negative 3x smaller than or equal to 24 minus 12. Okay, because I'm taking the 12 across. Okay, so it's 24 minus 12, which is 12. Alright, now I'm going to divide by a negative. Ooh. What did I learn in the previous example? I need to do something when I divide by a negative. I need to switch this. Remember, I need to flip it. Okay, so I'm going to divide by negative 3. Divide by negative 3. And before I give the answer, I'm going to flip my inequality first, before I forget. I'm going to flip my inequality. Okay, my inequality symbol. Okay, and this is going to be x, and this is going to give me negative 4. Alright, okay, when I'm done with my inequality, what must I always do? Represent it on a number line. Alright, so I'm going to draw a nice number line anywhere on your page, doesn't really matter where, right, as long as it's close to your working out. Alright, so they say x is greater than or equal to negative 4. Right, I'm going to put a negative 4 there. Okay, label negative 4. Are they including negative 4? Yes, this is greater than or equal to. So I'm including that negative 4. Okay, and it's greater than. Okay, greater than. Is it to the left or to the right? To the right, greater than. Okay, negative 4. All the values above negative 4. Alright, okay, let's move on. Ooh, okay, I see fractions again. Fantastic. Okay, what must I do with fractions? Quickly, tell me. Tell me. LCD, fantastic. Alright, so I'm going to get an LCD on both sides. Alright, so the LCD is 4. Okay, if you don't know how to get LCD, go watch my previous videos. You know how to do that. Algebraic fractions, go watch that video. Alright, what I do on one side, I do on the other side. Alright. Now, what do I do to 2 to get to 4? I times by 2, so I need to times the top by 2. Okay, so that's going to be negative 3 times 2, which is negative 6. And that's x plus 1. Okay, in a bracket. Then minus what I do to 4 to get to 4. Nothing, so that bracket's going to stay the same. Alright, and then what did I do? Okay, 12 is over 1. So what did I do to 1 to get to 4? I times by 4, and what's 12 times 4? Oh, awesome, it's 48. Fantastic. Okay, I don't like LCD, I don't like it. I don't like it. What do I do? Multiply. Awesome. Multiply by the LCD. Weggesê. Weg. Alright, now let me simplify before I write down. So I've got negative 6 times x, which is negative 6x. Okay, negative 6 times positive 1. Negative 6. Negative times 1. Negative 1. Negative times negative 8x. Positive 8x. Awesome. Okay, smaller than or equal to 48. Alright, now I want all my x's one side, all my numbers the other side. Okay, so I'm going to keep my x's here. Okay, all my x's on the right side. Fantastic. Alright, so let me just add them quickly. Okay, so I've got 8x minus 6x, which is just 2x left on the side. Okay, and then I've got the 48. Okay, and I'm going to add 6 and add 1. Okay, so technically I'm adding 7. Okay, and what is 48 plus 7? Good, it's 40. Sorry, 50. 55, very good. Alright, so 55. Alright, and we're going to, now I'm solving for x. Amazing stuff. Okay, so what must I do to solve for x? I divide by 2 on both sides. Okay, am I dividing by a positive? Awesome. Okay, I'm dividing by a positive. Does that mean I must do something with my inequality sign? No. When do I flip my inequality sign? When I'm dividing by a negative. Here I'm dividing by a positive, so I leave it the same. Okay, same direction. Alright, this is going to be x. Okay, and what is 55 divided by 2? Okay, we've got 27,5. Alright, so you can either use 55 over 2 if you like fractions, or you can use the 27,5. Okay, it will look nicer on your number line. Okay, so if I go and I draw my number line. Okay, so let me draw it here. Alright, there we go. Alright, so they say that x is smaller than or equal to 27,5. All right, so I'm going to go label 27,5. Okay, so you can either say 27,5 or you can say 55 over 2, whichever one is most applicable for you. Okay, whichever one you like most. All right, are we including 27,5? Yes, we're going to include it. Okay, and they say that x is smaller than or equal to 27,5. Is it to the right or to the left? It's to the left. All the values smaller. All right. Okay, I'm hoping you guys are getting the hang of this. Okay, nice and easy stuff, eh? All right. So let's look at this. Whoa, sir. Hold up. Wait a minute. Something ain't right. Okay, now I see. Whoa, sir. I see two inequality signs. Hold up. What's happening? All right. So now, okay. So remember in my previous equation videos. All right. I said. Remember when I said when you've got x plus 1 equal to 2, all right, and I say solve for x. Okay. A lot of you guys say, okay, I'm going to take this over. I'm going to change the sign. Now this is going to this, and then I said, no. Okay, we minus 1 on both sides, and minus 1 on both sides. That's where the negative comes from. Okay, then the ones cancel. I'm left with x and 1. Okay, so now this is where that is going to be important. You see, I'm looking out for you guys. Okay, I know these things. I'm a teacher. All right, so now let's see. Okay, so I see I've got a positive 1 here. All right, I've got a positive 1 here. Okay, I want to get rid of this positive 1. Okay, so how do I get rid of a plus 1? What's the opposite of a plus? A minus. So if I'm minus 1 in the middle, okay, what is 1 minus 1? 0. Okay, my 1s are going to cancel out. But I can't just minus 1 here in the middle. Okay, I need to minus 1 here. And I need to minus 1 here. Okay, can you see where my logic in my previous videos is coming in now? You see? So if you understand what I was telling you in the equations videos, I know some of you guys just breezed over it. Okay, and you were like, oh, this dude doesn't know what he's talking about. All right, I know what I'm talking about. Okay? Because this is what kids do. If you don't do this, this is what you guys do. You're like, okay, I'm going to take this 1 across here. Fantastic. I don't know where I'm going to take it across, but I'm just going to take it across. And I'm going to take this across. I'm going to get negative 7 minus 1. Right, that's x. And that's 12 there. Right, and I'm going to get, okay, this is going to be negative 8 x. Okay, and this is going to give you eier marks 0. Eier 0, nothing. All right, so please get rid of that logic of, oh, I'm taking things across. Okay, and I'm changing signs. Right, you need to understand what you are doing. All right, so we're minusing 1 here, minusing 1 here, minusing 1 here. So if I minus 1 in all 3 of these places, okay, what's going to happen here? Okay, I've got plus 1, minus 1, which is 0, plus x, it's just x. Okay, smaller than or equal to. All right, and then I've got 12 minus 1, which is 11. And over here, I've got negative 7 minus 1, which is negative 8. Okay, can you see how this was different to the previous answer? All right, but still, sir, no, but now my x is in the middle, sir. I don't know what to do now, sir. All right, whenever I solve an inequality, okay, what do? I always represent in the number line. Okay, so let's just draw the number line. All right, but now I've got 2 values here. Now I've got 2 values. All right, so how the heck, sir, am I supposed to represent this on a number line? All right, so let's see how we do this. Okay, so can you see they say that x is greater than or equal to negative 8. Okay, so let's go label the negative 8. So the smallest number goes where? To the far right or to the far left? Okay, we'll go on the left somewhere. Okay, because it's the smaller one. Negative 8 is smaller than 11. Okay, so we're going to put negative 8 somewhere here on the left. Okay, and we're going to put the 11 somewhere over here. Okay, there's the 11. All right, so they say they say that my x value, all right, is greater than or equal to -8. Okay, so it's including 8. Okay, I know that. Okay, but they also say that it's greater than -8. Am I going to the left or to the right? I'm going to the right. Right, but I'm not going to draw an arrow just yet. I'm not going to draw an arrow just yet. Just hold on. All right, now let's look at this 11. They also say, okay, that x is smaller than or equal to 11. Right, so is it including 11? Yes, of course it is. It's including 11 there. All right, and then it says it's smaller than 11. Smaller than. Which way am I going? To the right or to the left? I'm going to the left. Okay, so my line is going to join up nicely over there. Okay, so can you see that my x values are everywhere in between -8 and 11. So everywhere in between -8 and +11. So all these values in between here. So there's a -7 here, there's -6, dot dot dot, and we've got +10 here and a 9. So all these values in between here is what my x value could possibly be. All right, is that making sense? Okay, I'm hoping it's making sense. Okay, so let's see if we can do the last example for today. All right, again, I've got two inequality signs. All right, so what am I going to do? Am I going to take things across? No, I'm not going to take things across. Okay, what am I going to do? How am I going to get rid of whatever's here? Okay, because I want to solve x. Okay, so here's my x. How am I going to get x by itself? Okay, first thing I need to do, I need to take everything that's connected to my x, okay, my 2x, everything that's plussing or adding or minusing, whatever, I'm going to take that away. Okay, how do I get rid of a +1? What's the opposite of +1? -1. I can't just -1 here. I need to -1 there, and I need to -1 there. Okay, so if I -1 everywhere, all right, this is going to end up with 2x. Okay, and I've got my greater than, or my less than, all right, and then I've got 11 -1, which is 10. Okay, and I've got -7 -1, -8. All right, but I want x. Here's a 2x over here. All right, so I'm going to divide by 2 here. Okay, but then I need to divide by 2 everywhere else as well. All right, that's why we say we need to, that's why in equations, when we say we divide by 2, or we divide by whatever's in front of x, we divide on both sides. Now we're going to divide on all of the sides, on my left hand side and also on my right hand side. All right, so -8 divided by 2, it's -4. Okay, smaller than x, which is smaller than 5. Right, whenever I'm finished with a inequality, what do? I represent it on a number line. Fantastic. Right. Okay, so they say I've got a -4 and I've got a 5. Right. Which one's bigger? Which one's smaller? Okay, so the -4 is smaller, so I'm going to put him over here. -4. Okay, and I've got a big 5 over there. I'm going to put the 5 on the right hand side, on the far right. Okay, so the smaller number always goes on the far left, and the bigger number goes on the far right. Okay, now let's look at this. Let's analyze. All right, so they say that -4 is smaller than x, or x is greater than -4. All right, so is it including -4 here? No, so what am I going to draw? I'm going to draw a circle, right? And they say that -4 is smaller than x, or x is greater than -4. Right, so where's x greater than -4 here? To the left or to the right? To the right. Okay, x is greater than -4 to the right. And here they say x is smaller than +5. X is smaller than 5. Okay, so is it including 5? No. Okay, so, but they also say that x is smaller than 5. To the left or to the right? To the left. Okay, so all these inequalities are saying, okay, they just say that x is any value in between -4 and +5. Okay, all the values in between there. Okay, and this is what that number line represents. So it's all the values in between -4 and +5. So all these values, and not including -4 and not including 5. All right, Okay, I hope this video was helpful for you guys. I hope it helps you with your tests. Okay, be blessed and have an amazing week.